I want to be able to say a few things in real time about the electromagnetic spectrum. The electromagnetic spectrum, or EM spectrum, is what physicists call in totality light. And there's different kinds of light in the electromagnetic spectrum, and they range from having very long wavelengths to having very short wavelengths. What we normally think of as light is just this small portion in the middle. That is the visible range of the electromagnetic spectrum. And that's what the visible range is what we think of in a rainbow: red, orange, yellow, green, blue, indigo, violet, Roy G. Biv. And what took me a long time to realize is that it's actually fairly easy to remember the order of the different kinds of light in the electromagnetic spectrum if you orient yourself from visible. So on this end we have violet. Well, just to the other side, to the right of the violet light, is UV, which is ultraviolet. And then on this side, the left side of the visible spectrum, is the infrared. So we have red and then the infrared, which is usually abbreviated IR. The range in the electromagnetic spectrum that has the longest wavelengths are radio waves, or RF. Radio waves can be on the order of 10 to 15 meters. And in between radio waves and infrared are microwaves. Okay. Now on the other side of the UV, there are X-rays, and then finally gamma rays, famously known for creating the Incredible Hulk. It's important to note that the parts of the EM spectrum with long wavelengths have low energy. So radio waves, which have very long wavelengths on the order of meters, have low energy. And that's sort of easy to imagine because we use our radio to detect a radio signal, radio waves. On the other end of the spectrum, things have much higher energy. Short wavelengths, high energy. And if we think about that, for example, we have visible here. Ultraviolet light's a little bit more dangerous than visible light. UV has more energy than visible and can cause damage to the DNA. And then we know that X-rays, of course, can be damaging. That's why we protect the rest of our body when you're getting an X-ray. And gamma rays are actually just like very high energy X-rays. They have the highest energy among the types of radiation in the electromagnetic spectrum. All light in the electromagnetic spectrum travels at the same velocity, and we call that velocity c. That is the speed of light. And the speed of light is 3.0 times 10 to the 8th meters per second. So radio frequency waves travel 3 times 10 to the 8th meters per second, as do X-rays and gamma rays and visible ultraviolet. So, so I think of short wavelength as having high energy, and it's also high frequency. Frequency is abbreviated with nu. And I think about something that has short wavelength goes up and down very fast. That's a high frequency. That's high energy. In contrast, something with a long wavelength goes up and down very slowly, long wavelength, low energy. These are little devices that I have for trying to remember various aspects about the electromagnetic spectrum.